All right, everyone. Thank you. Thanks a lot for joining us. I'm Steve Yalga. Again, I'm the Director of Sales and Marketing with Dual Sign Products. Today, we're fortunate to have Tim Peel and Art Allen joining us today and presenting 10 techniques to extend the life of your bandsaw blade. Sounds like a really exciting time. These are two of our most seasoned and experienced folks on our team. Both Tim and Art will tell you a little bit about themselves, and then they're going to get to the meat. If you have any questions during this session, please put those in the chat. And at the end of the session, we'll try to go through as many of the questions as we can, and the ones that we can't get to, we will completely answer and send those off to you, everyone that's in attendance. So without further ado, here's Tim and Art, and enjoy, folks. Thanks again.
Well, good afternoon, everybody. I thank you for attending our webinar here. My name is Tim Peel, and I'm located down here in Texas, and I cover the South Central region for DuAll. I've been with DuAll 35 plus years, um, living here in Texas and loving it. So a little bit about this presentation is items that we took out of our DuAll University that we perform for operators on during different meetings. So I'll let Art tell you a little bit about himself.
All right, folks. Yes, thanks again for taking time out of your day to join us here on this webinar. I'm Art Allen. I'm the regional sales manager for the Southeast. I've been with DuAll going on going on 9 years now. I've been in the metal industry for pretty much my entire working career for 25 years, either selling metal or selling metal cutting machinery. And the first 4 years with DuAll, I worked directly for the DuAll saw blade factory. And the remaining 4 or 5 years, I am responsible for the DuAll bandsaw machines, DuAll saw blades, and coolant sales for the Southeast. I live in Newnan, Georgia, which is about 40 miles south of Atlanta. The first item today we're going to talk about is the chip brush, and it's one of the least expensive wear parts and also one of the most overlooked wear parts on a bandsaw machine, and it's very important in extending your blade life. The bristles of the wire brush actually clean out the gullets between the tooth tips. There's times when the blade travels through the material being cut and there's saw chips left in the gullet. And you do not want the saw chips in the gullet to travel back around and to re-enter the cut. When that happens, you have chances of the gullet overfilling, applying too much pressure, and something has to give. And that is almost always your teeth are going to start stripping. So there is a correct way to position the chip brush. You want the chip brush, the bristles, just barely touching the most shallowest gullet. You don't want to jam your chip brush up all the way into the blade, because essentially all you'll be doing then is cutting the wire bristles of the brush. So again, very important wear part, very important to extending your blade life. So what is wrong with this picture right here? Well, the left saw guide arm is too far away from the material you're cutting. Your right saw guide arm is in the correct position. You want the left side saw guide arm as close to the material as possible, because when you don't position both of them correctly, uh, your saw blade will actually deflect or bow upward. And when that happens, it causes stress cracks in the backing of the blade, extra fatigue, and then your blade will eventually break prematurely. This slide right here is a The picture is obviously an exaggeration a little bit, but the numbers are correct. You can see for every 2 times the span of the saw guide arm is too far from your material, your backing of your blade will actually deflect 8 times. So that is a great difference. Um, great deflection, and as I said, when that happens, you will develop cracks in your backing of the blade, and your blade will break prematurely. And as we all know, saw blades are not cheap.
We're going to talk a little bit about band tension. Every one of your saws, you always have, you put the new blade on, you tension the blade, but most guys don't understand why they're tensioning the blade. And basically, there's a lot more to it, but just to be brief, we are stretching this blade depending that different saw manufacturers have different specifications, but we're stretching that to eliminate deflection. When you get deflection, you start wearing set on the teeth, and once the tooth set is gone, it'll start cutting crooked. So band tension, if you don't have a tensor gauge, you either have a service tech come in and check the blade tension, but it needs to be set to the manufacturer's specs of the saw, and they do vary among different manufacturers. Next thing we're going to talk about is feed system. And feed systems is your actual how the saw's feeding through the material. And there is 4 types of feed systems in general. Your first system you will find on your lower end saws is what we call a closed loop hydraulic cylinder. Basically, all that's doing is bleeding oil from one side of the cylinder to the other, allowing the head to come down. It's controlled mostly with a flow valve. The next type of feed system out there is a servo valve system. Servo valve systems are kind of getting outdated, but the back of the blade ran against the backup, which was connected to a valve. So when you were putting excess feed pressure on the blade at the tooth, it would slow the feed rate down. Very high maintenance item. Like I say, most saw manufacturers went away from this system. Your next system out there, which is very common in your power saws, is feed rate and feed force valves. And basically, you're controlling your feed rate, and also the force is how much pressure you put on the tooth. You need to know which actually system you have so you're able to adjust them correctly to give you better blade life. And another name for that is a balancing valve. The next type of system, which is more used in the newer machines today, the more advanced machines, especially ball screw type saws. There's different types of modification of this, but this is what we call meter feed system. This is the feed system of the future. You will find this mostly on the higher end saws. So next thing is the blade sales catalog. And basically, this catalog has lots of information in it. And it would really be beneficial for you to have this catalog. If you don't have a catalog, ask your sales rep to get you one, or they're on our online on www.doallsaws.com. But in this has a lot of technical information. We spend a lot of time in the technical part of writing this catalog. So if you don't have one, I strongly suggest you to get one. Okay, here's one other important thing: breaking in your blade. Um, what does breaking in the blade mean? Does it mean taking it and throwing it across the floor? Is that how you break it in? I see a lot of guys do that, but that's not what we're talking about. So the main thing is breaking it in. It hones and strengthens the edge, and it will extend your tool life 25 to 50%. We have done this time in, did all testing, and every time we break in a blade, you will get much better blade life out of it. You ask me, how do you break a blade in? Well, number one, you do not change the band speed. You leave the band speed alone. This is where a lot of guys make mistake. And if you change the band speed, you are still putting a heavy tooth load on that tooth. The next thing we want to do is reduce the cutting rate for 1/2 of the rate. So say you're calculating, you want to cut this at 10 square inches. You now want to be breaking in at 20 square inches a minute. I mean, 20. And then you want to do that for 20 minutes. So take and cut half of your rate of what you were doing. And I said 20, but I really meant 5. So you're cutting a lot slower and doing this for 20 minutes. Breaking blades in, we do it different. I'm talking about bimetal blades. Breaking in a carbide blade is done different. And the big difference in carbide blade is you now do decrease the blade speed 70% of its value. So on bimetal, we did not decrease blade speed, but on carbide, you do, and you bring them up uniformly. So basically, if you look at this chart, you'll see a new blade. We really got a nice sharp point on that blade. After we're breaking it in, we're honing the blade. We're rounding it off a little bit. The bottom picture is if you don't break, you can see that tooth. It gets fragmented and gets chipped and there. So easiest way to explain this is think of a lead pencil. If I took a lead pencil and I sharpen it with a good point on it, I go to right, I push too hard, the point breaks. What do I do different? I don't push as hard. I hone that lead pencil in, and then I can start pushing and writing without breaking the tooth on it. Take it away, Art.
Thanks, Dale. Appreciate that. So another very important technique of extending your blade life is making sure you select the correct tooth pitch per the material you're cutting. So how do you do that? Well, as Tim explained in our catalog, it has a wealth of information and one chart in the back of our blade helps you select the correct tooth pitch. So for this example, if you're cutting a 6-inch round piece of material, look straight across the row up top until you get to 6 inches. And then you can look straight down the column. You can see there that your primary number one blade tooth pitch choice is your 2-3, 2 to 3 teeth per inch. But if you have a 3-4, that's also, you'll be fine with that. That is our secondary choice. So primary choice for a 6-inch round is 2-3. Your secondary choice is a 3-4. Both of them would work fine. So make sure you select the correct tooth pitch. All right, so you always want to make sure that you have a minimum of 3 teeth engaged and a maximum of 25 teeth engaged in the material. And why is that? Well, you you need to have a minimum of 3 teeth engaged because your saw head is a lot of weight, and if you only have 1 or 2 teeth engaged and you have the weight of the saw head coming down, you're gonna snap the teeth. You're gonna break the teeth off. So have a minimum of 3 teeth. And why do we say a maximum of 25? Well, if you have too many teeth going through the material that you're cutting, your gullets will overfill. And then when your gullets overfill, there's a lot of pressure. And what's going to happen? Well, with that pressure, something's going to have to give and you'll start stripping the teeth. So when you're cutting thinner sections, or thin metal, you want to choose a finer tooth pitch, more teeth per inch. When you're cutting your thicker sections or thick metal, you want to choose coarser pitches or less teeth per inch. Very important in extending your blade life. So it was real easy choosing the tooth pitch for a 6-inch round solid. It was basically one step involved. What about if you're cutting structural type of material like your channel, your angle, I-beam, or tubing? Well, it's still very easy. It's a 2-step process. So first, you want to determine how wide your structural material is, or in this example, letter B. And then you want to determine the thickness of the leg of the angle or the wall thickness of the tubing, which is represented by letter S. So once you determine letter B, you look across the chart, you find how wide it is, and then you go down the column of letter C, and you kind of connect the dots, the column and the row, and that will tell you exactly what tooth pitch that you should choose for that type of structural material.
Okay.
Go ahead and
We're
advance it,
gonna-
Tim.
Thank you there, Art. We're going to look at right now how figuring out cutting rates. Yeah, a lot of customers kind of just or operators, run their saw by what someone told them, but there is some math that got to be done, and we need to know this. So basically, you will find sawing recommendations. We have charts. Um, Somebody may have the old slide rule that still is available. You can find it on our app that gives you cutting rates. There's many different ways of finding them. But you need to be able to know basically one, what your band speed should be, and number two, how many inches per minute we're going to be cutting, getting our cut rate, getting that information off the chart. So here's the formula. What we're trying to do is we're trying to find time. And it's art. Area equals rate times time. So we know the cutting area, that's the material, whatever we're using, a round or a rectangular or a square. We can figure our square inches of our material. The cut rate we get off of the chart. That gives us our cut rate. And then cut time is how long it takes to cut that piece of material. That's the ultimate goal. If you're not cutting it at the proper speed, you're losing production, your cost per cut goes up. If you're cutting too slow, you can be sitting there and just honing that blade, rubbing that blade, and killing your blade life. So it's important to get a good cut time. Too fast, too slow, both of them will deteriorate and kill your blade life. So this is the formula to ask you to write it down and start using it. The next thing you need to know is your headfall. A lot of your saws today are working with headfall now. And basically what they do is they're saying, okay, my head got to drop 3 inches a minute, or my head's got to drop 2 inches. And there is actually scales on the newer saws of today. So to figure that, here's the formula. Basically, you take your material height, that then you divide it by the cut time, which you got from the other formula, and that will give you your head fall. So you can know exactly how fast that head is falling through material. So these are two formulas that you really need to know and practice in cutting. We'll gladly work with you to come in and work with you and help you get these proper, using these proper calculations. Back to you, Art.
Thanks, Tim. So the next 4 slides will show you our 4 most popular Dual saw blades. So the first one here is our Dual Silencer GP. This is the blade type that you will find your finer tooth pitches, like your 610, your 812, your 1014s will be your Silencer GP. This is an excellent all-purpose blade, excellent blade, especially if you're cutting tubing or pipe. It has a neutral rake angle on the tooth tip, which means the tooth tip points straight down. So it can take a lot of shock when it's going through say a thick wall pipe and it goes through the pipe and then it hits the opposite side. It can withstand a lot of shock. So our second blade that I want to talk about is our Silencer Plus. Again, it's a good all-purpose blade used mostly though in your solid type of materials. Uh, the finest tooth pitch the Silencer Plus comes in is a 5/8. So if you need a finer tooth pitch, like I just mentioned, you want to go with the Silencer GP. The Silencer Plus here is a more aggressive blade, has a positive rake angle, so the angle of the tooth tip is greater. It pulls a bigger chip, and it's a little faster cutting and more aggressive. The third one, the Structural blade, is a blade designed to cut, well, exactly as the name implies, structural type of material. So if you're cutting I-beams, angle, channel, this is your go-to blade for cutting your structural material. And what makes this one a little bit different is, as you can see in the circle right up under the word metal, we left more metal on the backside of each tooth, which makes each tooth more robust and stronger. So it prevents tooth breakage, and has a positive rake angle like the Silencer Plus. So it really pulls a good chip. It's more aggressive, and it's a little faster cutting as well. But this is the blade for your structural type of material. And your fourth blade is our penetrator, Dual penetrator blade. This is your number one go-to blade when cutting solid material. It has an even greater rake angle than the Silencer Plus or the Structural. It's very, very fast cutting, pulls a very nice big chip through the material. Does exactly what it says. It penetrates the material, very fast cutting. So these 4 are your most popular bimetal saw blades that we offer. Thanks, Tim.
Okay, so we basically did a real brief little covering, and most we could do in our time limit. But we covered a little bit about on machines, and we covered a little bit about blades. Now the third element of bandsawing is coolant. Coolant is very, very important. A lot of people think, well, the cooling is to cool the blade during cutting. Yes and no, but we're looking in bandsawing more for lubricity than we are looking for cooling properties. So there's four basic types of coolants, and we're going to start is you have straight oils, but nobody uses straight oils anymore. Most saws can't even pump straight oils. But our next starting coolant is a soluble oil. Soluble oil is a coolant that's mostly oil and water. It gives you some of the best blade life, best finishes. The downfall with it is it don't have a really great sump life. So, um, but if you're doing some hard cutting, look at soluble oils. Your next type of corn is a semi-synthetic. A semi-synthetic is going to have less oil than what is in a soluble oil. This can be anywhere from 5% to 25, even 30% oil. But synthetics, the nice thing about them, the sump life is a lot more friendly. The parts are cleaner. This is kind of becoming the preferred type of coolant for most operators. The next type of coolant out there is your synthetics. A synthetic has no oil in it. Uh, so, oil creates bacteria loves to thrive in oils. So, your sump life is much stronger, longer lasting in a synthetic. The other big advantage of a synthetic is looking at your next operation down the line. If you're going from cutting to painting, synthetics may be a way to look at because you don't have that oil base to clean up on off of the part. So your blade life is not as good as in the other ones, but this is a good alternative. So those are your three types of basic coolants that used in the market. The biggest thing is we look at how to mix coolants. What's the ratio? Again, I said we're looking for lubricity properties. In machining, you're mostly looking for cooling properties. So basically, what we do is we take 10 parts of water to 1 part of concentration. So that is how you mix. I don't care if it's a soluble, a semi, or a synthetic. They're all mixing the same in ratio 10 parts of water to 1 part of concentration. Okay, how do you mix corn? There could be a situation, and some of you might have a proportional meter that mixes your corn, which is a very good way of doing it. But if you're still mixing it in a can, so first thing you want to do is you want to get yourself a can and get some fresh water with a clean can. After you've done that, your next thing is to pour your concentration into the water. Don't be like a lot of people, put some concentration in the bucket and then use the garden hose to mix it. That does not work. You will get separation from the molecules that will wrap around. So always take and put concentration in the water. Once you've done that, mix that coolant up, get it ready to dump in the sump. And we always say, what does oil stand for? Oil in last. If you remember that, you won't go mixing it the opposite way. Art?
Thanks, Tim. As Phil mentioned, yeah, the really nice coolants to use, but if not mixed properly, they're just not doing their job. And how do you know if they're mixed properly or not? And it's by using a refractometer. And why do you use a refractometer? Is you want to make sure that the water and coolant ratio is mixed correctly. So even though you may have done it correctly the first time, especially during the summertime, the water will evaporate and you will need to adjust your or your coolant content, sometimes your water content, and you do that by using a refractometer. So on the top picture, once you use your refractometer, if you when you look through the lens, if what you see looks like the top picture, you're good, you're golden, everything's fine. If it looks like the bottom picture where the white and the blue come together, there's some haziness, some fogginess. It's just not a clear cut line between the two colors. Then you've got some issues going on where there's foreign type of oils, tramp oils have gotten into your sump. It may be just over time. It's just time to clean out your sump pump completely and recharge it with brand new coolant and water. So by checking your coolant with a refractometer, that will definitely extend your blade life if it's mixed correctly and if it's maintained correctly. Again, we thank you very much. As you can see, the map of the United States, there are 5 regional sales managers, with Tim and I being 2 of the 5. Tim is down in Texas in the green shaded area. I am in the southeast, the red shaded area. Out west, we have Dan Royer. Up in the upper Midwest, we have Dan Stump. And in the Northeast, we have Pat Schmidt. And then also we have Ren Gibbs, who is our saw blade specialist that can help you with any cutting application or saw blade. If we're not available, then Ren can be available to help you select the correct blade type per the material you're cutting. We appreciate your time. Thank you, everyone. I know your time is very valuable. Any questions? Let Tim and I know.
Yep, and we'll hang around a little bit if anybody got any questions to answer them.
All right. We didn't see any in the chat. You can feel free to contact us directly. We'll answer any questions that you may think of later. Thanks again, everyone. At this time, our webinar is concluded. Have a great rest of your day, and Merry Christmas to all of you.
Thanks, everyone.